Okay.
Guitarists in this room have been having problems with this amp. When they plug in their guitar into it and touch another guitarist, they get shocked. We're going to explain why.
Through numerous experiments, we have found that the plug for this amp is missing a grounding wire. You can plug it in the right way, but also since it's missing the grounding wire, you can plug it in upside down. This builds up a charge in the guitar, which needs to discharge through another guitarist's grounding wire. We can demonstrate this with the voltmeter, which we'll show you in a minute. This is what a standard plug should look like. This right here is the grounding wire. That's what's missing on the other plug, causing it to build up a charge. We have connected this guitar up to the voltmeter and to this bolt right here. This will allow us to measure the voltage. We can also use this device to measure the amps. However, when we look at the recorder, it says 0, 0. That means that there is no current. The way we can explain this is that a guitar acts like a capacitor.
Through our experiments, we plugged this amp into this splitter. We discovered that the splitter's grounding wire is broken, so this creates a dangerous situation.
Okay, I'm Harrison, and we will head to the lab and I'll explain why there's current building up in the amp going to the guitar and how this will cause the discharge to happen in this amp.
Because I'm feeling smart right now, I'm going to prove to you all that this does shock us. Go!
Here we are in the lab, and I will show you how the guitar and amplifier work. The guitar itself has a bar magnet, which is the pickup. When you run current through there, it allows for magnetic energy to be converted into electrical energy. So when you oscillate or vibrate the strings, it breaks up the current in a signal that's running through the magnet, and thus produces a signal to run through the amplifier. So we have the circuit of the guitar. When you run current into the input jack here, the current runs this way, up through the wires to the pickup coil where the magnet itself is. Thus, to generate the signal, which is has the current broken up into little tiny pieces, that runs through here. You have your tube volume knob, your tone knob, and your volume knob, which then amplify or diminish the current by a little bit, so you have a longer current stream or a fatter one, which runs through the resistors, and then it comes back down to the output jack, which is the same thing here. So for the amp, although it looks very complex, it is quite simply this. You have your input jack for the guitar, which then runs current through this resistor, the capacitor, through here. There are many more volume knobs and such, but basically it'll run all the way through here and out to the speaker. So how we have the charge building up in our amp is by the plug here. You have a mega resistor here, which when you have the amp plugged in and it's off, it still has current running through it. When you turn the amp on, this opens up and has the current flow through by the arrows through here, going this way. So comes down and then splits here, so one half of it goes to the jack and then the other half of it comes down to the speaker and it gives a hum until you strum the guitar. Now the multiple resistors and the capacitor on the way to the input jack an output jack where the amp argues to make it that no current can build up in the guitar. However, as we've shown with the reverse of the plug being upside down, it allows current to be built up into the guitar but not expelled, thus making the guitar like a really crude capacitor, since wood does not discharge electricity. That's why when the guitar touches another, it's then able to have the current discharge and have a shock. And our works cited where we got our info.